Welcome to College Algebra, Module 2, Topic 2.2, Types of Functions and Their Rates of Change. Objective 1. Types of Functions, the constant function. A function f represented by f of x equals b, where b is a constant or a fixed number, is a constant function. The graph of a constant function will be points on a horizontal line. The y-intercept of a line will be the ordered pair 0, b. Let's do an example. Graph the function f of x equals 3. Notice there is no x value on the right side of the function, therefore the y value is always 3. So if we made a chart, the f of x is always 3. The x can be whatever we choose, so we could plug in 0, 1, 4, -2. It doesn't matter, but the y value or the f of x value is always 3. So to plot these ordered pairs, we would do the ordered pair 0, 3, which is over 0 up 3, 1, 3, which is over 1 up 3, 4, 3, which is over 4 up 3. Notice we have a horizontal line that passes through the y-axis at 3. A function f represented by f of x equals ax plus b, where a and b are constants, is a linear function. In this form, a, or the number in front of x, is the slope of the line, and b, the number at the end, is the y-intercept. If a is 0, then f of x equals b, and f is a constant function. Therefore, every constant function is also a linear function. The graph of a non-constant linear function is a line that crosses both the x-axis and the y-axis. Therefore, it's not a vertical line and it's not a horizontal line, but it's a line that is slanted somehow. Let's do an example. For each linear function, identify the slope and the y-intercept. Well, remember, a linear function is f of x equals ax plus b. The number in front of the x is the slope. The number at the end is the y-intercept. So for the function f of x equals 4x minus 9, the slope, which is the number in front of x, which we'll call a, is 4. The y-intercept, which we'll call b, is the ordered pair 0, -9. For the function g of x equals -1 plus 6x, same thing. The slope is the number in front of the x, so the slope is 6, and the y-intercept is the ordered pair 0, -1. And then for the function h of x equals 4, there is no x term, which means the slope is 0, and the y-intercept is the ordered pair 0, 4. Objective 2 is slope. Slope measures the steepness of a line. Slope can be thought of as the ratio rise over run, but slope is basically just how steep the line is. There are 4 types of slope. Positive slope means that the line rises as it goes from left to right. Negative slope means the line falls or goes down as it goes from left to right. So if we had a line that looked like this, because going from left to right it rises, this would be a positive slope. A negative slope is one going from left to right that goes down, or we say falls. That would be a negative slope. The third type of slope is zero slope. that means that the line is a horizontal line, just like the constant function that we did. And then the fourth type of slope is an undefined slope, and sometimes we'll write the little undefined symbol, which is the zero slash. And the zero slash represents the slope of a vertical line. The slope of the line passing through 2 points, x1, y1, and x2, y2, is found using the formula m equals the change in the y values divided by the change in the x values. Remember we said slope was rise over run? Well, rise is the difference in the y values, and the run is the difference in the x values. The slope of a horizontal line will be 0, and the slope of a vertical line will be undefined. Let's do an example. Find the slope of the line passing through the following pair of points. Now, just to get an idea of where we're going, if we plotted those points on a graph, 4, 3 would be over 4 up 3, negative 6, negative 9 would be right here. You notice the line is actually going up from left to right, therefore we know we're going to have a positive slope. So if we go through and say x1, y1 and x2, y2, to find the slope, we're going to do y2 minus y1 over x2 minus x1. So when we plug it in, that means the second y value, which is negative 9, minus the first y value, which is 3, over the second x value, which is negative 2, minus the first x value, which is 4. So up on the top we get negative 9 minus 3, which would be negative 12, divided by negative 6 minus 4 would be negative 10. Well, negative 12 over negative 10 would reduce to give us 6 over 5. Now, as a note, a slope of 6 over 5 means that every time the line rises 6 units, it runs 5 units. That is, for every 5 unit increases of x, there is a 6 unit increase of y. And we can look up at our graph. Every time we rise 6, 1, 2, 3, 4, 5, 6, we run 5, 1, 2, 3, 4, 5, and we're back on the line. Then when we rise 6 and run 5, we're back on the line again. Another example. Find the slope of the line passing through the pair of points 5, negative 2, and negative 1, negative 3. Then interpret the slope. Well, let's do it again. Let's label our points. X from the first point, Y from the first point, X from the second point, Y from the second point, and write our slope formula, which is y2 minus y1 divided by x2 minus x1. So when we plug our values in, the second y value is negative 3 minus the first y value is negative 2 divided by the second x value, which is negative 1, minus the first x value, which is 5. So in the numerator, minus a negative 2 becomes plus a positive 2, and we get negative 1 divided by negative 6, which would give us 1 over 6. Interpret the slope means every time the line rises 1, it runs 6. For every 6 unit increases of x, the y increases by 1. And one more example. Find the slope of the line passing through the pair of points 4, 1 and 8, 1. Then interpret the slope. Well, again, x1, y1 for the first point, x2, y2 for the second point. Our slope formula, y2 minus y1 divided by x2 minus x1. Plugging in the points, we get 1 minus 1 on the top, 8 minus 4 on the bottom, which would give us 0 divided by 4, which is 0. Now remember, we said a slope of 0 meant that the line was a horizontal line. We could look at the graph. The first point over 4 up 1, the second point over 8 up 1. Therefore, we have our horizontal line like we expected. Now, just a caution, if we would have come up with a 0 in the denominator, then because there's no such thing as division by 0, we would have had a fraction that was undefined and the slope would have been undefined. But since the numerator was 0, then the fraction has a value of 0 and the slope is 0. Remember that a linear equation is an equation of the form y equals mx plus b, where m is the slope and b is the y-intercept. Also recall that the slope of the linear function f of x equals ax plus b is a. Notice that the linear function and the linear equation are exactly the same form except for the coefficient of the x. Well, a linear function can also be written as f of x equals mx plus b, where m is the slope and 0, b is the y-intercept of the graph of the function. Sometimes we'll use m, sometimes we'll use a, but just know that the number in front of the x value is the slope. The slope of a linear function is its average rate of change. Okay, let's do an example. Find the slope of the line f of x equals 3x plus 2. So for that graph, the slope is 3. Example number 2. Find the slope of the line f of x equals 4 minus 8x, then interpret the slope. Well, again, the slope is the number in front of the x value, so for this problem the slope is negative 8. And what that means is, if you write this negative 8 as a fraction, we would get negative 8 over 1, which means for every change of y of negative 8, the x value changes 1. Or we can say for every change of 1 in the x value, the y value changes negative 8. An application involving linear functions: the amount of money in dollars raised each year by a band booster club can be estimated by the function f of x equals 189x minus 371,620, where x is the year between 1990 and 2000. What is the slope of the graph of f, and what does this mean? Well, the amount of money raised in dollars is given by the formula f of x. The number in front of the x is the slope. So for this problem, the slope would be 189. If you consider the fraction 189 over 1, so what it means is each year the amount of money earned by the booster club increases by $189. Another example: a runner's distance d in miles from home after x minutes is given by the formula d of x equals 0.1x. How far from home is he after 30 minutes? Well, the formula d of x is the number of miles from home after x minutes. So after 30 minutes, that means find d of 30, which means d of 30 is equal to 0.1 times 30, or 3.0. That means after 30 minutes, the runner is 3 miles from home. The next part says find the slope of the graph of d and interpret this slope as a rate of change. Well, the slope is the number in front of x, so our slope is going to be 0.1. Interpret this as a rate of change. Well, 0.1 is 1/10. So what that means is every 10 minutes the distance from home increases by 1 mile. Let's do another application. In 1984, the average annual cost for tuition and fees at private four-year colleges was $5,991. By 2004, this cost had increased to $20,082. Find the average yearly increase in cost between 1984 and 2004. If we looked at a graph of these 2 points, the first point is the 1984 $5,991 graph. The second point is the 2004 $20,082 point. The line passing through those 2 points represents the increase of the tuition and fees. So the first thing we want to do is to find the slope of that line, or the average yearly increase in cost between 1984 and 2004. Well, if we consider this to be x1, y1, and the second point to be x2, y2, and we plug it in our slope formula, which was y2 minus y1 divided by x2 minus x1, the average yearly increase in cost was $705.55. Objective 3, Nonlinear Functions. The definition of a nonlinear function is any function that is not a linear function. Nonlinear functions cannot be put into the form f of x equals ax plus b. Some examples of nonlinear functions is f of x equals 4x to the third minus 6x squared plus 1. Notice we have an x to the power of 3 and an x squared. Therefore, they are not linear functions. Another example is 7x to the power of 2.49 plus 8. Again, we do not have x to a plane power, therefore it cannot be a linear function. F of x equals the square root of 6 minus x. Because of the square root, nonlinear. And f of x equals 5 over x plus 2. Because we have an x in the denominator of a fraction, nonlinear. There are 4 basic types of nonlinear functions. The first one is the square function. In order to be a square function, you have to have an x to the power of 2. And the general graph of a square function is the parabola. If x is 0, 0 squared is 0. If x is 1, 1 squared is 1. If x is 2, 2 squared is 4. And same thing back on the other side. If x is negative 1, negative 1 squared is 1. If x is negative 2, negative 2 squared is 4. So your graph would look something like that. The domain of any square function is all real numbers. We could plug whatever we wanted in for x. The range of this square function is going to be everywhere from this point 0, 0 all the way up to infinity. So the range for this one would be all y's greater than or equal to 0. The second type of a nonlinear function is a square root function. Now the typical graph of f of x equals the square root of x looks like this. It's sort of like half of the parabola turned sideways. The domain for the square root function for x, because you cannot plug in an x as a negative number under the square root sign, the domain is going to be x is greater than or equal to 0. Well, when you take the square root of a positive number, then the range, or the y values, is also going to be a positive number, including 0. So the range would be all y values greater than or equal to 0 as well. The next type of nonlinear function is the cube function. Well, the cube function, or x to the third, if we just plugged in some points, if x is 0, 0 to the third is 0. If x is 1, 1 to the third is 1. If we plugged in -1, -1 to the third power is -1. If we plugged in 2, 2 to the third power is 8. If we plugged in -2, that means -2 times itself 3 times would be -8. So what it's going to look like is 0, 0, over 1, up 1 this way, back 1, down 1 for the other point. The next point, over 2, up 8, is going to be way up here, and the next one, back 2, down 8, is going to be way down here. So what we've really got for an x to the third function is something that looks like that. The domain for a cubic function would be all real numbers. We could plug in whatever x value we want and raise it to the third power. The range, there are also no restrictions on the range, because no matter what number you plug in, it could go really high in one direction or really low in another direction, so the range is also all real numbers. And then the fourth type of a nonlinear function is the absolute value function. If we wanted to plug some points for the absolute value function, if we plugged in 0, the absolute value of 0 is 0. If we plugged in 1, the absolute value of 1 is 1. The absolute value of -1 is also 1. If we plugged in 2, the absolute value of 2 is 2. If we plugged in -2, the absolute value is 2. Remember, absolute value is the distance from 0 on a number line, which is never negative. So the graph of that, there's 0, 0. The next point, over 1, up 1. Third point would be back 1, up 1. The fourth point would be over 2, up 2. And the next point would be back 2, up 2. So what this graph looks like is a V-shaped graph. The domain, or this absolute value, is going to be all real numbers. We could plug whatever number we wanted in for x. But the range, notice there are no range values down here in the negatives, so the range would be all y's greater than or equal to 0. We're going to use these four basic types of nonlinear functions when we start doing graphs. Okay, let's do some examples. Identify each function as linear or nonlinear, and if it's linear, tell if it's a constant function. Well, because the highest power of x is 1, or this function is linear. G of x equals -4x. Well, that could be thought of as -4x plus 0. You have an x to the first power, so that one is also linear. The third function, well, this one has an x squared. Therefore, it's not linear. The next one, m of x equals -6. Well, there's no x value, so you could think of that as 0x minus 6. This is a linear function whose slope is 0, which in this case, remember, it's a linear function, but it's also a constant function. And then the last one, the square root of 2x plus 1, because it's a square root, that is nonlinear. Objective 4, the average rate of change. If x1, y1 and x2, y2 lie on the graph of f, then the average rate of change of f from x1 to x2 is given by the formula y2 minus y1 divided by x2 minus x1. Sometimes you will see this formula as the f of x2 minus the f of x1 divided by x2 minus x1. Notice this looks a lot like the slope formula. This just says to get the y value when we do functions, remember we call those f of x rather than y, but basically it is the slope of the 2 points coming from those two functions. The average rate of change of a constant function is 0. Well, your constant function graph is a horizontal line, so for any 2 points we pick on that line, the rate of change is 0. The y values do not change at all. The average rate of change of a linear function, f of x equals ax plus b, is the constant number a. Well, think about it. If you have a linear function, the graph is a straight line, so if you pick any 2 points on that line, then the rate of change is just going to be the slope. It's when we start doing nonlinear is when the average rate of change varies a little bit. For instance, if we had a graph that looked like this, the average rate of change from this point to this point is the slope of the line that passes from this point to this point. Okay, let's do some examples. The first example says, use the graph below to calculate the average rate of change as x goes from 0 to 3. Well, x is 0 is right here at the origin. That is the ordered pair 0, 0. When x is 3, that is this ordered pair right here on the graph, which is the ordered pair 3, 0. Now if you look from x is 0 to x is 3, notice the graph actually moved. It went way down and now it's coming back up. But the rate of change, just looking at those 2 points right there, the graph did not change at all. So what the average rate of change formula says is if you have 2 points, then we're going to plug it in our formula. y2 minus y1 divided by x2 minus x1. So in this case it's 0 over 3, so the average rate of change is 0. Now what if x goes from 3 to 4? Well, if x is 3, that was this ordered pair right here, which was 3, 0. But if x is 4, that puts us all the way up here at the top, which was the ordered pair 4, 5. So we have the ordered pair 3, 0 here. We have the ordered pair 4, 5 here. And we basically want to calculate the slope of the line going from x is 3 to x is 4. So when we plug our slope in now, we would get x1, y1, x2, y2, which would give us 5 minus 0 in the numerator, 4 minus 3 in the denominator. So their average rate of change from 3 to 4 is 5. The next example, find the average rate of change of f of x equals x squared plus 1 as x goes from negative 2 to 1. Well, we need some ordered pairs. So if x is negative 2, f of negative 2 means you plug in negative 2 for x, so that would be negative 2 squared plus 1, which is 4 plus 1, which is 5. So this gives us the ordered pair negative 2, 5. F of 1 means we're going to plug in 1, so that's 1 squared plus 1, which is 1 plus 1, which is 2. So when x is 1, y is 2, so our second ordered pair would be 1, 2. Once we know our 2 ordered pairs, we're going to use our slope formula. So it'd be y2, which is 2, minus y1, which is 5, divided by x2, which is 1, minus x1, which is negative 2. Simplifying that, we would get negative 3 divided by positive 3. So the average rate of change for this function from negative 2 to 1 is negative 1. Now, what about as x goes from 3 to 5? Well, same thing. If x is 3, we need the y value or the function value to go with that. So if we plug it into our function, f of 3 is 3 squared plus 1, which is 9 plus 1, which is 10. So our first ordered pair would be 3, 10. Our second ordered pair, f of 5 means 5 squared plus 1, which is 25 plus 1, which is 26. So our second ordered pair would be 26. So to use our rate of change formula, remember it's y2 minus y1 divided by x2 minus x1. So we'd get 26 minus 10 divided by 5 minus 3, which would give us 16 over 2. So the average rate of change is 8 from x is 3 to x is 5. Okay? One more. Find the average rate of change of f of x equals 3x minus 5 as x goes from negative 4 to negative 2. Well, same thing. F of negative 4 would be 3 times negative 4, which is negative 12, minus 5, which would give us negative 17. F of negative 2 would give us 3 times negative 2 minus 5, which is negative 6 minus 5, which is negative 11. So our ordered pairs are negative 4, negative 17, and negative 2, negative 11. So to do our rate of change formula, we would get negative 11 minus negative 17 divided by negative 2 minus negative 4. Well, minus a negative becomes plus a positive in each case. So we would get 6 divided by 2, so the average rate of change is 3. Now, did you already know that? Probably so, because if you look at that, your function was a linear function with a slope of 3, so it really didn't matter which 2 points we picked. The average rate of change was going to be the same as the slope, therefore it was 3. So without even doing this one, as x changes from 2 to 4, we know that the average rate of change for this linear function is going to be 3. Now you can work it out if you want to, but I'll bet the answer is going to be 3 again. Objective 5, linear or nonlinear functions using a table. So we want to determine if the data in the table is linear or nonlinear, and if it is linear, give the slope. Well, remember, a linear function, the x values change at the same rate that the y values change. So for this problem, it's hard to look at it and go, oh yeah, the x's all increase by the same amount every time, because they don't. So what we're going to have to do is check the slope between several of the points. So if we wanted to find the slope just on the first 2 points, it would be 0 minus negative 25 divided by 2 minus negative 3, which would give us 25 divided by 5. So the slope between the first 2 ordered pairs is 5. Let's look at the next 2 ordered pairs. That would be 10 minus 0 over 4 minus 2. That one is 10 over 2, which is also 5. Looking at the next one, we would have 15 minus 10 over 5 minus 4, which would give us 5 over 1, so the slope is 5. And we could do that throughout, but from the looks of it, We could also graph it, but I would say that this one is linear and the slope of the line would be 5. Okay, let's do it again. To determine if this data is linear or nonlinear, we're going to look at the x values and the y values and make sure they are consistent. Every time we have a change in y, we have the same change in x. Well, notice on this one it's a little bit easier to look at because this increases by 2, this increases by 2 every time. The y values, the first time it decreased by 12, then it decreased by 4, then it increased by 4. You notice it's not consistent, therefore there's not the same rise over the run pattern. So in this case, this one is nonlinear. We could also look at a graph and tell that the graph is not a straight line. You are now ready to do the homework for Module 2, Topic 2.2 in my math lab. Once you've scored at least a 90% on 2.1 and 2.2, you'll be ready to take the Module 2 quiz. Remember, you must have notes from both sections in order to take the quiz.